Let's now talk about a very important TypeScript features about the generics, and this is a more advanced feature of TypeScript. Well, they simply are an extra layer of abstraction over regular types, so we can use generics to build more and more stronger types. And you can think of them like parameters for types. If functions have parameters, then also types can have parameters, and a type with some parameter can be called a generic type. This is the terminology. Well, why do we need generics? We will see a broader and more complex examples inside this section, but we can say that we can use generics or types with generics to reduce code duplication and build stronger types. And talking about generics, they are essential if you want to understand TypeScript advanced types. So in the next sections, we will also start to talk about more advanced TypeScript types. Well, you need to know generics before diving into advanced types. Well, what can you expect from this section? First of all, we will try to give a simple definition and some simple types to some simple examples to generics. Then we will talk about some popular generics, talk about generics constraints, and talk about generics for multiple types and generics for classes, interfaces, and types. This being said, let's get to work and get first of all an introduction about TypeScript generics. In this lecture, we will write our first generic and we will understand better what this contract between function argument and return value types really means. And to understand this, let's start with a very dumb example, a dumb requirement just to make a point, doesn't have any logic. But let's say that we have a requirement from our manager who has a lot of ideas. He needs us to build a function that wraps its argument into an array. Well, fair enough. Let's think about how we can do this and let's build our function. Well, this is our function and it's exactly what our manager wanted. We have this toArray function. It receives an argument. It receives any argument because anything inside JavaScript or almost everything can be wrapped inside an array. Fair enough, that's great, and let's now use this function. Well, that's great, it works really well. Let's see what the type of this array looks like after we call this toArray with a string. Well, it's an array of any, and here we have a big problem with this implementation. Even if it does exactly what it's supposed to do, we don't have types or the right type annotations for it because we are using TypeScript and we want to have strong types inside our language. Well, what solution would we have in this problem? And maybe you are thinking, if you are in this situation, why we are even using TypeScript if we have more problems than solutions? Well, let's wait a little and you will see why. Well, one solution to this problem would be to just have a function that accepts typed arguments. Let's say that we have this toArray from string which receives an argument of type string, and this for sure will return the right type of array of type string. Again, an argument that receives numbers. It will return back an array of numbers, or array from boolean, or array from object, and so on, so on. But you might see the problem with this second approach. Even if all these functions they do exactly the same thing, in order to keep our types, to have strong types inside our implementations, we need to provide each function its own implementation, just to have these return types as they should be. Is there a better way in which we can do this? Yes, of course, and the answer for this problem is generics. Well, let's give this function another chance and let's try to write it down again, but this time using generic. Let me make some room right here. So again, we are starting from our implementation to array, which receives an argument of type any and returns a array from this argument. Well, we want to add a contract between this argument and the return type of this value. Well, in this case, let's say that this argument can be of type any type, This is usually the convention when we are using generics, like to have an uppercase letter, but not always necessarily. And this argument of type should return, this function should return this type wrapped into an array. But at this point, TypeScript has a huge problem because it doesn't know what this type means. What do you mean by this type? You know, even if you want to return an array from this type, what this type means. Well, this is the point where we are introducing the syntax of generics. We can specify that this type is a generic argument to this function. And at this point, TypeScript knows that what this type is and what the return type should be. Well, this is the very basic implementation of a generic function. Even if it is very basic, you need to understand it very well in order to understand generics. And why is that? Let's use this function. Well, we are now using this generic function just like we did with the other implementation, but as we can see at the type of this array, now it has the proper type. It even have a stronger type, a more exact type. It is a string wrapped inside an array. So this is great. This is the way we can use arrays. We can use generics. But as you can see, we are using this function, but we didn't specify inside this function where we are calling it that we want this toArray to be called with a string type. That is the reason, because even if we are specifying the function argument right here, when we are calling the function, TypeScript will be smart enough to know that if this argument is of type string, then this array only accepts strings, and this will know from type inheritance that this t is string. I can even hard code it or specifically say right here that we want this toArray to be of type string, and then this type should match the function argument. If again we are having a typo right here, or we are not passing the right thing, we would have a compilation error. But like with other ways in which TypeScript does this type inference, also this calling of functions which use generics is not really necessary to specify the type right here, when TypeScript can directly infer it from its usage. Well, this is the basic way in which we can use TypeScript generics. Let's move on into the next lecture and talk about some popular generics that we use with TypeScript. Let's quickly see two examples of generics that you will use very often. At least one of them we already used a lot inside this course, and I'm talking about the way we are using and declaring arrays in TypeScript. As you can see, we have two ways in which we can declare arrays in TypeScript. Until now, we used this direct declaration with a string array, the type, and then the array declaration. And this way will for sure make TypeScript know that this array of names can only support strings. For example, if I want to pass a number, it won't accept it. But the same way of declaration, we can do it by using generic types. And here we are using a type of array, and this array we are specifying that it receives a generic type of string. If we hover over this array, you will see that this is an interface declaration, an array of type, and this kind of interface declarations are used by TypeScript to give us this strong type support for different built-in functions of JavaScript. Either way in which we are declaring arrays is exactly the same, and it will give us strong type support as we've seen before. Let's look at another example, a more complicated example, and we will talk about some asynchronous code. We will have a dedicated section on asynchronous code, but for the moment let's only observe the types and the generics. And let's look at this implementation. Let's say that we have an external service, an API that we are connecting internally from our application that returns us a different types, different data from our internal server. Let's say that we have a service, an internal service that will return us some employees. We have this type employee, which has a name and a role, and we have a function getEmployees that accesses a service with the newly improved fetch function from Node.js and the browser. For sure you will do this at least a few times inside your project. Well, we have this await fetch from a URL. And as you can see, currently I didn't added any type inside this function. I just specified that this is an asynchronous function. If we look at the return type of this function, as soon as I specify that this is an asynchronous function, you'll see that TypeScript will add this annotation to its return type. It will tell us that this is a promise of any for the moment, because we didn't specify anything. Well, this asynchronous, as soon as we are having this asynchronous annotation to our function, TypeScript will directly transform its return type into a promise. And remember, again, disclaimer, if you don't know too much about promises, we will learn a lot about them in the next following sections. For the moment, let's check this implementation. We are only accessing an external service, then we are parsing the result, and we are returning this parsed result. This JSON function from the fetch library returns again a promise of any. So we don't have any types, even if we are sure that this external service will return a promise, will return an array of employees. How we can add some stronger types to our implementation? Well, very simple, by using generics. And we can say that these employees can return multiple types of data. Maybe we have a service that returns managers, one service that returns different other positions. Well, let's just say that this getEmployees returns a generic type of T, and then it will return a promise of T array, like this. And as you can see, this is all what we did right here. We only added some generics. But now if we will call this function with the await keyword right here, what will be the type of these employees? Let's take a second to guess. Let's see it and save it. Yes, it's still unknown, because at this point, if we want stronger type, of course, we need to annotate this type right here. So we want to say that we want these employees to return employees. Well, we added this type right here, and now these employees will be of type array of employees. That's great. And with this annotation, we can have strong types inside our API responses. A last note for this lecture, we have here returning a promise of T array. We could again use the other syntax, array of T. It is exactly the same, but maybe if you are a beginner, you haven't seen too much generics, this might look a little stranger, hard to read. Maybe you prefer the other way of using arrays like this. Maybe it is easier to read for you. Let's move on into the next lecture and talk about generic constraints. Let's continue the discussion about generics and talk about something else. The way we can use generic constraints or limitations or bounded generics, or whatever you want to call them, is by us trying to limit the way in which we use generics inside our code. What I mean by that? Let's look at this simple example I've put on the screen. And let's say that we have a narrow type called object with theme, which just contains a theme of string. Then we have a programmer which extends that object. Okay, until now, let's say that we have a function, a very unclean way in which we can update a field inside a function. Well, let's say that we have a function update theme. This function receives an argument of type object with theme and just assigns a new value to this argument. Nothing new until now. We can solve this problem just by using plain old TypeScript. We don't use generics. Well, generics would also allow us to solve this problem in a different way. Let's see how we can do them. So we just can specify this object with theme as a bounded generic inside our function. So here we can say that this function accepts an argument of type T that extends our object with theme. This is it, and now our argument will be of type T, and it will be exactly the same. We can use this function with other arguments that extend this object with theme. And notice here the syntax, even if for types we use this character, well, for extending types inside the generic definitions, we use the extends keyword. And of course, this is valid also for interfaces or also for basic types like string or number. Well, this approach will allow us to, for example, if we want, we can just return this object back. And here we can just say return our argument. This would be the only advantage that this approach would bring, even if we wouldn't want to do this in the real life. I just wanted to show you how we can use these generic constraints. Another way in which we can use generics and generics constraints are when we are building different types. Let's take a different example. Well, we can have generics also inside types. We will have a dedicated section only to advanced types in which you really need to know about generics in order to understand the more advanced types in TypeScript. Let's say that we have this type, old school programmer, which as a language only extends something like BASIC or Lisp or other old programming languages. We can solve this problem also with generics, and this type can also accept an argument of t extends BASIC or Lisp. Well, when we are declaring this an object of this type, we can specify this BASIC type inside the type arguments, and now the language for this colleague will be just BASIC, can only be BASIC. Of course, we can only accept the types that are extended by this, so we can't have typos right here. And the last point I want to make in this section is that for generics, we can also have default types. For example, this t extends BASIC or Lisp, but let's say that we want, in case we don't specify anything inside this type definition, to this generic type to resume to this BASIC. We can do this by using this syntax, and we can just give it a default value for this type that it is BASIC. And in this case, we don't need to specifically specify this language, it will just resolve to BASIC. So this was the way in which we can use generic constraints inside TypeScript. Let's move on into the next lecture and talk about multiple generic types for our functions. Let's now see another problem that we can solve with TypeScript generics and also learn something new about them, the multiple arguments for generics. Let's see the following problem. We have two roles inside our company, a Scrum role and a Product Owner role, but you know, since the economy is not working so well, we have decided to merge these roles. And we have created this function, merge roles, which simply takes some objects and just merges them using the JavaScript spread syntax. This is the way you can simply combine together two objects, take their keys and just make one object from two objects. What's the problem with this implementation? Well, there's nothing wrong functionally, but if we want to, again, keep our types, we will see that the type of this Scrum Product Owner role, the broader type, is simply an empty object. So we don't have any type assistance right here, and this is just sad because we like TypeScript. How we can solve this problem with generics? Well, we can simply say that this merge roles accepts arguments of type object, and that will be okay. Let's see if this is working. Again, let's say that this function receives an argument of type t that extends objects, because this function only accepts objects, so this t extends object, and now our first role is of type t and the second role is also of type t. We already have a problem right here. What is the problem? Because this t extends our object, and now our both objects are objects right here. Why we have a compilation error right here? Let's look at the error message, and this will say that property teams is missing from our second type. And the reason for this problem is that when we are calling this merge roles function, this t type right here is inferred from the first argument. So if the second argument is different, then we will have a compilation error. Well, how we can solve this is by giving a new type right here. So this merge roles function receives an argument of type t that extends object, and an argument of type, let's say, g, or doesn't really matter, that then again extends object. And here we can just say right here, and the compilation error is solved, and also let's also solve our problem, and this returns t merged with g, or in the intersection, better said, the intersection of these two types. Now if we look at the type of our Scrum product owner role, you will see that it has all the types: the holds meetings, the teams, the holds meetings again, and the reports too. And of course, the second way in which this holds meeting is called, it will just override the first call. So at this point we have autocomplete and type assistance for this object. Well, this is just one simple solution in which multiple types for our generics solved us. You can see we have a unlimited, now we can call unlimited types of generics inside our functions. We can simply then use them inside our implementation. And sometimes one generic type is not enough, we need more. Let's proceed into the next lecture and talk about how we can use generics with classes and interfaces. Just as we have generics with functions, in TypeScript we can also have generics for classes. And when we are declaring a generic function like we are having in this example, we have an add item generic function which accepts an item of type t. Instead of specifying what t is inside the function, we can specify what t is inside the class declaration right here when we have its name. For example, here we have a class called memory database which can handle any type of arguments of type t. This is just instantiating a simple array of type t, and then we can make simple operations based on that array. You can see when we are declaring this type of generic value at the beginning of the class, then inside the class TypeScript will know that where we are specifying this t, it will know its type. For example, everywhere inside this class, since we have this generic type t right here, everywhere these items are of type t, right here, right here. So inside this class, the generics, the TypeScript will know that these items are of type t. And let's check the implementation. As you can see right here, we have a names database which holds strings, and we can add items strings, and when we are trying to get them, we can see that we are getting a string or an undefined, of course, this if this item doesn't exist. But let's take things to the next level. Since we have classes, this means that we can also have inheritance. Well, let's say that we can extend this memory database class with some items that we can also delete. Maybe we can't just always add things to this class and not deleting them. But if we want to delete items inside an array, we need a way in which we can find that item. And let's say that we have a class that needs items to have an ID. This way, this class definition right here, we have two ways in which we are making extensions. First of all, the generic type extends a type which has IDs, and then we are also extending this generic class memory database of type t. The only problem right here is that we are trying to access these items which currently are private. Let's just make them simple protected, and then everything will be good to go. So this way we can take all the functionality inside this memory database of type t and add something new to it, of course also by keeping the generic logic. And again, if we want an implementation of this, we can simply make it one with just add item with an ID. The cool thing is, again, we are keeping our types. As you can see, this first ID has an ID, which is great. Let's move on into the next lecture and also talk about interfaces and types in the light of generics. In TypeScript we can also have generics for types and interfaces, and I guess that this is the most popular way in which we will use interfaces, mostly on building complex types. For example, here I have a very dumb type, a double array, which takes two generic arguments, a t and a r, and then declares other arrays with these t and r types. Well, very simple. And also, again, we can use interfaces with generics just like we use types with generics. I can even say right here interface instead of type, and just quickly change the syntax and everything will be exactly the same. And talking about interfaces, we can use again generics in interfaces just like we did with classes. We can declare the type upstairs and then we can use that type inside the body of the interface, maybe building a blueprint or a contract for a class. For us, I have a simple interface for a memory database. This is again another way in which we can use interfaces. And a very quick note before ending this lecture: interfaces and generic interfaces are used by TypeScript to build a whole strong type system for JavaScript. If we will press Ctrl and then press this array, we will build this ES 2015 types. I can open it right here, and as you can see, this is just a type declaration for arrays of t, but this is a great way in which you can see how the TypeScript documentation uses generics and interfaces to add strong types to JavaScript functionality. You can see this right here. If we go right here, you can see all the documentation of TypeScript. For example, there's a big chunk of documentation in this DOM entry right here, when you can get all the documentation about working with browsers. Well, this being said, we can end this lecture and this section about generics. Of course, there's still a lot of things to learn about generics, and you can learn them with combining them with complex TypeScript types, just like we will do in the future.